What's up, YouTube? Trent here with Visual Torch, where cybersecurity meets clarity. Today, we're going to have kind of a packed video for you. Did miss a couple of days, so we're going to actually be streaming days 19 through 22 for TryHackMe's Advent of Cyber. And if you're new here, TryHackMe all month has been doing a 24-day challenge where they release new beginner-friendly rooms, and every day you're getting topics such as malware analysis, blue team work for detecting malware, and cloud security, and the various other topics. So each day that you complete a room, you will get a ticket to go ahead and enter into a prize pool, and the pool of prizes total over $150,000. So it's a great way to score some great merch and some great toys, hacking toys that is, throughout for the end of the year. So if you just stay tuned, we'll go through each of the days. So we'll go ahead and get into today's stream. So now we are on day 19, which is covering ICSs and Modboss. Cause for concern is the name of today's room. So I apologize for not streaming. I was just completely tired and not feeling it on Friday. So I just needed to take some time to recover. So just remember, it's always good to take some time to take care of yourself. As we go through this, if you have any questions, feel free to type them in the chat. If you have any questions about cybersecurity or just anything in general, just type it in the chat and let's just talk. So we're on day 19 of the story, and it's saying that snow falls heavy over Wareville as chaos erupts at the TBFC headquarters. What should be the busiest shipping day of the year has turned into disaster. Another chocolate egg, shouts a frustrated warehouse worker holding up yet another Easter-themed package. We're supposed to be shipping Christmas presents. So all through this whole Advent of Cyber campaign, the evil Easter bunnies they've been jealous of Christmas. So they have been trying to find a way to divert Christmas and fill it with Easter because they felt Easter should have more of a presence. So this is the theme that we're going with. So delivery drones buzz overhead, their mechanical hums sounding almost mocking. Each one returns from its route empty, having successfully delivered its cargo, but the cargo all went wrong. So we're called to the command center where the screen flickers with delivery statistics. Everything looks normal on the surface. There's 1,000 presents in stock with a 98% success rate, and all systems are operational. But the phones won't stop ringing with confused citizens asking why they're receiving chocolate eggs instead of toys and gifts that they ordered. The logistics manager pulls up a delivery manifest. Say, look at this. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but it's on completely different items. So on the monitor, we get this exploit, property of Hopsec Island. Why should Christmas have all the fun? So someone has compromised our drone fleet's control system. This isn't just a prank, it's a calculated assault on Christmas. So our mission is to investigate the TBFC drone system, uncover how King Malware's exploit team compromised it, and restore Christmas before Sockmas is ruined. We must be warned, King Malware does not leave systems undefended. Traps are waiting for a careless investigator, and one wrong move could make things very much worse. So we actually are going to pick up this crumpled piece of paper, which is saying it's the drone registry map. And it's a bunch of these things, HR0, HR1, there's Boolean flags, things are true. We see package selection type is either a Christmas gift, chocolate egg, or Easter basket. So this is probably what is causing things to go haywire. And I was checking inventory. It looks like there's a merge key dump location. There's a Christmas restore flag. So that should be what I think would get us to restore everything. And if we scroll down, it says that this is a registry map with coils, but it all looks foreign. But something about feels important, like a key you don't know how to yet use. So we pocket it carefully, and we'll figure out what it means later. So our current objective is how SCADA, which is Supervisory Control and Data Acquisition System, monitor industrial processes. We'll learn about programmable logic controllers and automation. We'll see how the Modbus protocol enables communication between these industrial services. We'll learn how to identify compromised systems, configurations in industrial systems, and techniques for safely remediating compromised control systems. And we'll understand the protection mechanisms and trap logics in ICS environments. So I went ahead and started our attack box for us. So we'll go ahead and we'll get started. Check. Need to join the room. No, we're here. Oh, no answer needed. Okay. So what is SCADA? So SCADA systems are the command centers of industrial operations. They act as a bridge between human operators and the machines doing the work. So we can think of them as a nervous system of a factory. It senses what happened, processes the information, and sends the command to make things happen. So in this case, the TBFC is using a SCADA system to oversee its entire drone delivery operation. Without it, operators will have no way to monitor hundreds of drones, manage inventory, or ensure packages reach the right destinations. It's an invisible orchestra of Christmas logistics. So we're going to be going over the components of a SCADA system. So there's our sensors and actuators, and these are the eyes and hands of the systems. The sensors measure the real-world conditions such as temperature, pressure, position, and weight, and the actuators perform the physical actions. So when the motors turn, the valves open, and the robotic arms move. So in this warehouse, they are detecting when a package is placed on the conveyor belt, and then they are controlling the robotic arms that load the drones. Then we have the programmable logic controllers, and these are the brains that execute the automation logic. They read sensor data and make decisions based on programmed rules and send commands to the actuators. So it might decide that if a package weight matches a chocolate eggs and the destination is zone 5, it will load it onto drone 7. And then it also has monitoring systems where these are visual interfaces like CCTV cameras, dashboards, and alarm panels where operators observe the processes. So in this case, TBFC's warehouse security will be on port 80, which will show real-time footage of everything being packed. And then we have historians, which are the databases that store operational data for later. Every package is loaded, every drone is launched, and every system change gets recorded. So it helps us identify patterns, troubleshoot problems. In incident response scenarios like ours, we can reconstruct what the attacker did. And so while we're just talking about drone systems here, ICS and SCADA systems are used throughout, and some of them are very foundational to what we do in the nation. Like I remember there was like the first known ICS hack or breach that happened. I think it was into the oil pipeline a few years back. So if you remember that, just think of these are the type of systems that they were attacking. So in this specific SCADA system, we have several critical functions. There's the package type selection, where it decides whether to load the Christmas gifts, the chocolate eggs, or the Easter baskets. Then we have the delivery zone, where each packet must reach the correct neighborhood. Zones 1 through 9 is different districts of Wareville, while Zone 10 is reserved for disposal. The ocean is a fail-safe for damaged good, but also the perfect target for sabotage. That's crazy, kind of just dumping things in the ocean. We know pollution is not what we need, but it is a story. Visual monitoring, which is the CCTV camera feeds that provide real-time observation of the warehouse floor. And we can see what exact items are being loaded. We can verify system behavior and identify anomalies. We have the inventory verification, which is before loading a package, the system can check whether the requested item actually exists in stock. We have the system protection mechanisms, or security features designated to prevent unauthorized changes. When enabled, these protections monitor for suspicious modifications and can trigger defensive responses. Unfortunately, King Malware has weaponized these very protections as part of his trap. Then we have the audit logging, where every configuration change, every operator login, and every system modification should be recorded. Attackers often turn off logging to cover their tracks, and that's precisely what happened here. So, why are SCADA systems targeted? Well, they become increasingly attractive targets for criminals and nation-state actors, like I was saying in the oil line hack that happened a few years back. So they often run legacy software. It's very hard to update them. They're pretty much not connected to the internet a lot of the time. So for someone to actually go there and physically update it manually, that's where these vulnerabilities can come into place. Security patches that exist for modern software don't normally exist for these aging systems. A lot of times they run off default credentials, and administrator prioritize keeping systems running over changing passwords. So often if it works, just don't touch it, which is often a recipe for security disasters. They're designed for reliability, not security. They want them to be on. They can't afford for them to be down. So that's where any of the slight inconvenience could have from using best known cybersecurity practices, they're probably not going to go with. They're intended for closed networks that are presumed safe. They control physical processes. Unlike attacking a website or stealing data, compromising SCADA systems have real-world consequences. They can cause blackouts, contaminate water supplies, in our case, sabotage Christmas deliveries. And they're often connected to corporate networks. The myth of air-gapped industrial systems is largely false, meaning they think there's no way for them to actually be connected, but sometimes they do go to business networking for reporting, and that can be a barrier of entry. That can be a point of entry. And then we have protocols like Modbus, which lack authentication. Many industrial protocols are designed for trusted environment. Anyone who can reach the Modbus on port 502 can read and write values without proving their identity. So in early 2024, the first ICS and OT malware, Frosty Goop, was discovered. It can directly interface with industrial control systems via the Modbus TPC protocol, enabling arbitrary reads and writes to the device registers over port 502. So King Malware weaponized the same tactic, did not cause blackouts, but sabotaged Christmas deliveries by directly manipulating the control systems through the Modbus protocol. So we can see here it's asking us our first question, what port is commonly used? So we know it is port 502. I don't know why it is not letting me. Let's just refresh the page and see what is going on here. It logged me out. Just give me 1 second. Let me log right back in. Okay, we are back. Sorry for that. It just completely didn't want to let me in. All right. All right, there we go. Now we're getting our stuff. So if we go back down here, this was port 502. And now we'll jump down to the PLC and Modbus. So PLC is programmable logic controller, is a industrial computer designed to control machinery and process real-time environments. So unlike a laptop or smartphone, they're purpose-built machines engineered for extreme reliability. They're designed to survive harsh environments. So they operate flawlessly in extreme temperatures, constant vibration, dust, and electromagnetic interference. They run continuously without failure. They operate 24/7 for years, sometimes decades, without rebooting. Remember, they just care about it being up. They execute control logic in real time. They respond to sensor inputs within milliseconds. So when a package reaches the end of a conveyor belt, the PLC must instantly activate the robotic arm to catch it. And they interface directly with physical hardware. They connect to sensors measuring temperatures, pressures, weight, and actuators, and they speak the electrical language of machinery. So then we have, what is the Modbus? It is the communication protocol that industrial devices use to talk to each other. And it was created in 1979 by Modicon, and it's one of the oldest, most widely deployed industrial protocols in the world. So we can think of it as our basic response, request and response conversation. So we'll have our client, which is the computer, and it will talk to the PLC, which will be the server, to ask like, what is the current value at register 0? And it'll tell you it is 1. So this simplicity makes it easy to implement and debug, but also means security was never a consideration. There is no authentication, no encryption, and no authorization to check. So if you can reach the Modbus, you can read any value. So here we have the different types of coils, discrete inputs, holding registers, and input registers. And we will just scroll down. So it says in the TVFC's control systems, we'll find that we'll have holding registers, which are writable, and they are HR 0, 1, and 4, which is the package type selection, the delivery zone, and the system signature. So in this case, an attacker's calling card. And then we had the coils, which are also writable. So we have C10 through C15, which will tell us whether inventory verification and protection mechanism is either enable or disable. It lets us know if we have the emergency dump protocol. It let us know if logging is enabled, the Christmas restoration flag, and the self-destruct mechanism. So each data point in the Modbus will have a unique address. So we can think of it as a house number on a street. So the critical detail here is that Modbus addresses start at 0 and not 1. 0 indexing catches many beginners off guard. So I remember seeing this like in programming, like a lot of arrays started with 0. So that's kind of how you can kind of remember that. So when documentation says register 0, it means the first register, not the second. So the first register here is the packet type selector, and so forth and so forth. So originally Modbus was operated over serial connection using RS-232 or RS-485 cables. So you had to actually physically connect to those. You had to go to the actual location and plug those cables in. But now that they use Modbus, now that it uses TCP, they can now go over a network. It can now send network packages to it. So it gives enormous benefits such as remote monitoring, easy integration with business systems, and centralized management. So King Malware exploited the vulnerability of this isolated system, and that's how the TVFC's drone control system was accessible over the network. So like we said, no authentication, no encryption, no authorization, and no integrity check. So we can drop down here, and right here it says that to understand why OpenPLC web interfaces shows nothing useful, King Malware bypassed it entirely and it connected directly into the Modbus over the TCP port, and that note we found, the maintenance technician must have discovered what was happening and started documenting the compromised values. So the one at the bottom says never change HR0 whilst C11 is true. So it figures out that there's a trap mechanism. So we'll now be using PyModBus, which is a Python library, to directly interface. So we'll go ahead and check this off and go to the next. Go to the actual practical. Okay. So now that we understand the basics, we are to analyze the compromised TBFC drone system. So here they want us just to do a regular Nmap scan and see what ports are open. And it should show us that we have 2280 and a 502 open. And this right here is just for us if we want to run a more extensive scan, which remember the TACP tag will let us see every single, it'll scan across all ports. So the key finding that we should return is that we have port 80, the HTTP service, which should be the camera feed, and 502 for the Modbus TCP. So if you're just now tuning in, we are going over day number 19. We'll be going over day 20 through 22 as well after we finish this. But what we can actually do, so I'll wait for that to finish, we can just go to this web browser and we should be able to see the CCTV feed. And here we can see the eggs on the conveyor belt that they were talking about from before. So minimize this. That is still running. So yeah, so if we scroll up now, yep, we have port 22, port 80, and port 502 that is open. So now we are going to see, oh yes, it also did say that it was compromised up here. So we got to return this back to normal. So this is where we're going to use PyModBus. So it tells us steps 1 through 5 are optional, and we can just read along. So let's go ahead and install Modbus. Go ahead and clear this out of the way. And let's go ahead and install Modbus. So it is done. So we have to establish a connection. Let's see. We can do Python 3. And then connect to the port. And try copying all this. But it's going to give us all of these little values here. So like we're going to be using Python. We're going to be using Python for a while. So what I went ahead and did was actually copied and pasted all that into Sublime, and we shall see how it works. Okay. So let's go ahead and do this first part. Then we have to establish the connection. So let us know if we are connected here. Like that. And let's hit it again. Connection failed. Oh, my machine IP did not go. Oh, I put in machine IP. So it is 10.80.166.154. Sorry, I did that before. I copied it before I finished starting up the machine. let's do this again. So yes, so we connected to PLC successfully. And then now we have to do the reading registers part. So we're going to look at HR0 and find out exactly what it's going to say. So if it hits 0, 1, or 2, we will be able to figure out what it's actually doing. Hit this again. So right now we have chocolate clover eggs is showing as the as HR type, and I actually went ahead and copied this over here. So you can see this is what we're going to be checking for. And then it says that means the system is configured to load chocolate eggs. The node is right. This is exactly what is causing the problem. So now we're going to check the delivery zones. So if we go in here, and hit it again. Normal delivery zone of 5, so it's not throwing things into the ocean. Now we're going to go into the system signature. So we're looking to see if that signature of 666 is available. So we can see here that the system signature is that exploit was detected. So it has been compromised by the exploit framework. So now we're going to read the reading coils, and we will see if inventory verification is enabled or disabled. All right. This again. So inventory verification is disabled. So it's not actually checking to see if we have anything in stock. The next thing we will be doing is checking coil 11, which is the protection override. We put this in here. You can see that changes are being monitored. So like it's noting here that back in the note, it says that we never change HR0 while C11 is true. So we'll trigger a shutdown. So it seems like that's where the trap is going to be made at. So it says next we will check if the self-destruct is armed. We'll go right here. And it's not armed yet. So we are going to avoid the self-destruct. So set understanding the trap. So HR0 is set to 1, which is sending chocolate eggs. Monitoring is enabled for C11, and anyone who changes HR0 while C11 is true, it will then arm that self-destruct. So we don't want that to happen because we want to keep the systems up. And after 30 seconds, the emergency dump will activate and everything will go into the ocean, into zone 10. So what we're going to do here next is they want us to complete a reconnaissance script. So they want us to nano, but since I'm already in Sublime, I'm just going to create a new file. And we will copy and paste this following code. So let's just put this over into our Sublime. Now we can put this here. And let's name this reconnaissance.py. Then I will actually actually, we need to exit out of here. And we'll clear this. And if ILS, my reconnaissance will be here, but I actually want to make it executable, which you can do by using chmod plus X and then the actual name. All right. And then now, if we just run it, it did all that we were just doing just by using the script. So we do see the same thing. HR0 set to 1. The delivery zone is normal. They did detect the signature. And then the inventory was false. Protection override is on. And everything else seems to match. So it says that the trap is set. The package type is forced to eggs. And the inventory verification is disabled. So, yep, this was just them running the script here. And then self-remediation. So based on our reconnaissance, we know that we need to disable the C11, the protection mechanism first. Then we need to change the package type to Christmas gifts. We need to enable inventory verification and then turn back on logging. And we need to verify that C15 never got armed. So they actually created a restoration script for us. So we can just go ahead and create another file. And I will copy this again. This is a long, long script. It looks like. Now we can paste this in here and save this as, we'll say restore Christmas. All right, and then I will make this executable again. And now we can run this. Run, verify system. Disabling protection, changing the package type, turning logging back on, and then it looks like we now have our flag too. So if we had changed HR0 before disabling C11, here's what will happen. It would have self-destructed, the 30-second countdown will begin, and then we would, everything would be starting to get dumped into the ocean. And all the remaining inventory will be dropped, and the CCTV will show the track activation screen. So speaking of that, let's see if it actually refreshed. Oh, system restored. So didn't even need to. Oh, was it? Stuff blow up in the background? Yeah, it did, and the egg spilled over. Okay. So now, King Malware attacker was sophisticated because it used unauthenticated Modbus access, it manipulated configuration values, and it disabled safety mechanisms. It implemented a trap, and then he left his calling card. So what we can go ahead and do is now just copy and paste this flag. And I didn't get the whole thing. No. All right, there we go. And check this. We are done with day number 19. We got our ticket. So now we can move on to day number 20. Go back to Wareville. And this one is going to be race conditions, toy to the world. So let's put everything back here. Let's just go ahead and just clear this. probably won't need this. So now we are on day 20. Okay. Actually, okay. Yeah, we have this one. Okay, so the TBFC has launched a limited edition sleigh toy with only 10 pieces available at midnight. So within seconds, thousands have rushed to buy, but something strange has happened. More than 10 lucky customers received a confirmation email stating that their orders were successful. So confusion spread fast. How could anyone have bought the last toy? So McSkitty quickly noticed that multiple buyers purchased at the same exact time, slipping through the system's timing flaw. So Sir Carrot Bane's bandit bunnies have found a way to exploit this chaos, and the flooding and checkout with rapid clicks. So many angry shoppers were missing stock, and and the mystery revealed how dangerous a few milliseconds could be. So we'll be learning about race conditions, what they are, and how they can affect web applications. We'll learn how to identify and exploit them using web requests, and how current requests can manipulate stocks or transaction values. Explore simple mitigation techniques to prevent race condition vulnerabilities. So we'll go ahead and start up this other machine. And let us in. So while wait for that, we will go over race conditions. So a race condition happens when two or more actions occur at the same time, and the system's outcome is going to depend on the order in which they finish. So in web application, this often happens when multiple users or automated requests simultaneously access or modify shared resources at the same time. If proper synchronization isn't in place, this can lead to unexpected results such as duplicate transactions, oversold items, or unauthorized data changes. And so they're usually divided into three categories, which the first one is going to be time to check to time of use. So it is a race condition that happens when the program checks something first and uses it later, but the data changes in between. This means that what was true at the time of check may not be true any longer when the action happens. It's like checking if a toy is in stock, and by the time you click buy, someone else has already bought it. So for example, two users buy the same last item at the same time because the stock was checked before it was updated. You have shared resources, which occurs when multiple users or systems try to change the same data simultaneously without proper control. Since both updates happen, the final result depends on who finishes last, creating the confusion. And then we have atomicity violation. An atomic operation should happen all at once, either fully done or not at all. When parts of the process run separately, another request can sneak in between and cause inconsistent results. It's like paying for an item, but before the system confirms it, someone else changes the price. So it's time for some action. So in this one, we are going to be using Burp Suite, which is a great vulnerability web application testing tool. So when you have if you use Firefox, it's perfect because you can use something like Foxy Proxy, which would be right here, that you can go ahead and turn on. So we will click on Burp just to make sure that all our requests are going to initially be sent here. It's going to be sent to our Burp Suite before it actually gets to the website. So if we open up Burp Suite now, and we have used Burp Suite in a couple of rooms before. So it was one that was, trying to remember which that room. It's one of the earlier rooms you did use Burp Suite. So if you did watch those videos, this should be a little bit familiar. Go ahead and click next. We'll use Burp's default. Burp has a community edition. Burp comes installed in Kali Linux. So if you're looking for a penetration testing framework, or you're trying to create a VM, Burp is in there. If you want more advanced capabilities, Burp does have a pro license. You can even get certified in Burp. We'll say no to this. And maybe I click this twice because this is up. Oh, click the line. If we scroll down, we start a burp. So now it says we will use proxy and repeater to exploit the race condition. So it says that first we need to make sure that intercept is turned off. Go to proxy, we will turn it off. Yeah, this step ensures that Burp Suite no longer holds our requests so we can pass them through normally. So we need to go back into Firefox and go to this website. We'll go 10.80.145.47. We are here. Do we have a username? Yep, we have attacker. And then we have attacker at 1, 2, 3. Okay, so we see we have the slate with 10. It wants us to go to cart and then select checkout and then confirm and pay. And we will see that we successfully completed our order. So now it says to exploit the race condition. Let's go back into Burp and go to HTTP history. And we should find the post request to the process_checkout, which should be this one right here. It says to right click and send this to the repeater. So now if we go here to repeater, it wants us to request says repeater here. So we need to right click on this and click add group to tab. And it says to create a group named cart. We'll create this. And then now we will go down and we will duplicate this tab. Let's put 15. Let's duplicate that. So now we'll be able to send the multiple requests at one time, so we can simulate exactly what they did. So it wants us to actually click this drop down and click send in parallel. So they'll all be going at the same exact time to try and do the race condition. And it should cause a bug with multiple orders because we only have 10. So we're trying to do more than the 10. Let's go ahead and send the group in parallel. We're getting order IDs. So now if we go back here, if we click on view orders, we should see that all these orders were completed even though our stock went down to -7. So if we go back to shop, we have our first flag here. So the mitigation for race conditions is the mitigation. So the attacker logged in and made a normal purchase using Burp Suite. We're able to cancel the request and send it multiple times. So because it didn't handle the checkouts correctly, each request is seeded before the stock could update. So the few mitigations we want to use atomic database transactions. So stock deduction and order creation execute as a single consistent operation. We want to perform final stock validation right before committing the transaction. We want to implement idempotency keys for checkout requests to ensure duplicates aren't processed multiple times, and apply rate limit or currency controls to block rapid repeated checkout attempts from the same user or sessions. So we go here. This is our flag. So why I keep missing the T on here. All right, put this in here. So now they want us to repeat the same steps for the that we just did, but they want you to use it for the bunny plush blue, which is this one. So let's actually go back in here and clear everything else out. So if we close all tabs and group, I'll just close this one out. So we're going to do the same exact thing. So let's go back here. Let's add a plush bunny to cart. Let's go ahead and check out. We'll confirm and pay. And now, go back to Burp Suite. We should see the other post get request. So actually, let's scroll down because this number goes in order. Okay, here is the one that we just sent. Let's send that to repeater. Let's go ahead and make a group off of this. Just name it cart. Again, how many did we have up there? Let's just do 15 again. So we will duplicate this tab. We'll put 15. Let's go ahead and send this in parallel so that way all of them are being sent at one time. And if we send it, we'll have our order ID. Go back here, go to view orders, and see we had 10, and now we're at -12. So go back to shop. Now we have our last flag. Here. Copy this. And then it just does not want to take 15. All right. There we go. So we did complete room number 20. 2 more rooms to go. So if you are enjoying the video, please do us a favor, like, subscribe, and hit that notification bell so you can follow along as we complete the rest of the days. We have 2 more. So I actually will not be able to get to these till about Sunday just because of traveling and the holidays. So we're going to take another few days off. So this next one is malware analysis using the malware.exe. Let's see. Sure. Let me close this out. And see if I get the split view back on. Okay. Maybe my machine ran out of time. We will boot this back up. Boot this. Let's see if we can get it attack box back up. Is the attack box down here? Should be. Okay. Let's just go ahead and start it up. Okay, so while we're doing that, we will go through the introduction, where on day 21, the day is just like any other. Thousands of files of all kinds pass through our system, from docx to PDF resumes to financial spreadsheets. Have you ever wondered which one of these may be malicious? Which ones could belong to key malware? An interesting question, isn't it? So what's going to happen in this one, we will investigate a specific file type, which is the HTA format, a file often used for legitimate purposes, yet it's just as frequently exploited by attackers. So our mission is to reverse engineer the HTA and uncover how King Malware tricked the L's. To look, and with this, we'll be looking at application metadata, script functions, network calls, or encoded data, and we'll get clues about the exfiltration. So we will start our attack box and we will open a malware sample. So this system uses malware. It's safe, but do not run it locally. It's intended for experience, and we need to use our attack box for it. So that's why all of these boxes are now. We can't use it in a bunch of other things. So the file is already there to provide it. We can download it manually. So it'll be in this Pluma root folder in day 21. Check this. While that's loading, we'll just go over the overview. So not too long ago, which was actually this summer, they discovered a ransomware groups were using HTA files described as fake verification pages to spread Epsilon Red ransomware. So many organizations were affected, and security teams were reminded how important it is to understand what HTA files are. We will go ahead and do this. Let's actually, I feel like we're going to need to go there. Let's actually copy this over. So we have it in our clipboard. All right. So we scroll down here. Put you there for right now. So HTA files are attractive because they combine familiar web markup with script execution on Windows. So did it actually, oh, sorry, scroll down a little bit too far. So HTA files are actually short for HTML application. They are small, they're like a small desktop app built in familiar web technology such as HTML, CSS, and JavaScript. So unlike regular web pages that open up in a browser, they run directly on Windows through a built-in component called Microsoft HTML Host Application, which is MSHTA. So in legitimate uses, HTA files serve as several practical purposes in Wareville and beyond. So automating administrative tasks or setups, providing quick interfaces for internal scripts. They'll provide small prototyping without building full software, and they offer lightweight IT support utility. So they're designed to be convenient, which will blend simplicity of the web with the power of desktop applications. So it's before the defenders of TBFC can recognize the suspicious HTA files, it is important to understand just how the normal HTA file is built. So the structure is quite simple. So there's an HTA declaration, which it can use basic properties like title, window size, and behavior. They will have the interface of HTML and CSS, and you will use some type of script such as JavaScript or VB script. So you can see here, this looks just like a regular HTML file with your head, your body, your H3 for your header 3. And it looks like that this is creating a button that says hello. And then when you click on it, it'll say hello message from Wareville. So we're going to go into how King Malware turns HTAs into weapons. So they're attractive because they combine the familiar web markup with script execution on Windows. In the hand of a defender, it's a handy automation tool, but in the hands of someone wanting to bypass security controls, they can use as a delivery mechanism or launcher. So the purpose of malicious HTA is initial access and delivery. They're often delivered by phishing emails such as attachment, fake web pages, or downloads. They then have downloads or droppers in them where they can download additional binaries or script from a C2 service. They are able to provide obfuscation and invasion because they can do things like encoding data with base64, which we were seeing when we were using CyberChef earlier. And they have a technique called living off the land, where they try and use built-in Windows tools such as the MSHTA, PowerShell, WScript, and RunDLL32 to avoid adding any more binaries on disk. So if we take a look down here, we can see what was going on in just a sample key malware script. So we had our title, we had our HTA application, but then when we get here, we actually have a script where it's going to be using VB script, and it's using PowerShell, and it's using the execution policy bypass, so it can try and run more commands that PowerShell would normally think is malicious. And then right here, it is base64 encoding some type of string, and it looks like it is trying to get a web request to a URL. So yeah, this is just explaining everything that I just kind of went over. And yeah, the execution policy bypass command, it's a pattern commonly seen in malicious HTAs used for delivering or launching. And we can see that if we go down here, this is the base64 encoded string. And it looks like it goes to this C2 sliver service that they are being used. So it was trying to definitely download this redacted.txt file. Sliver is a free open source C2 tool that's used in a lot of pen testing activities, but also because it's not, Cobalt Strike was actually what I was thinking of last time we were talking about C2s. This is Cobalt Strike is like thousands of dollars. They have opted for utilizing something like Sliver. Once it was new, it wasn't signatured as much. So it says in the example, we redacted the remote source and replaced the rel link with redact.txt for safety. In a real incident, that string will point directly to a file hosted on the attacker's C2 domain. So after encoded PowerShell command, there were 3 key variables that was up there, which was U, C, and B. So the variable U holds the decoded URL. It's a location in which the next script or payload will be fetched. The variable C was storing the content downloaded from that URL. It's usually a PowerShell script or text instruction. And variable B converts the content into an executable script block and runs it directly in memory. So whenever we see a chain of variables like that, try to trace whether it is created, used, or passed. And we'll see different functions like run, execute, or eval, and that's a sign that the downloaded data is being executed. So when we're looking at a suspicious HTA, we need to make sure that we're identifying any scripts that's in there. We're looking for any encoded data or external connections, which could be using base64 or HTTP request. And then we want to follow the logic to see what it is actually being executed. So we'll drop down here from survey to security failings. So our team has found out that some L's laptops were compromised. Working through the incident, it seems that the common denominator between them is all of a survey that was completed regarding their salaries. The investigation found that email was sent to these L's with a HTA attachment. So we're being asked to review the file and provide feedback on actually what is going on. We can use the attack box, and we will go to this file location here. This would like to load up. And now we'll open up and we will see this HTML file. So this is what it's going to look like. It says we can start by doing our searching of the header. You can see it's called the Best Festival Company Developer Survey. And if we want to look down, we can see that we have, let me actually full screen this so this is a little bit better. So we have JavaScript text here. Scroll down, we have some VB script. If we go down here, this is where the actual functions at that we wanted to take a look at. So we see that we have these get questions being done. We have a base64 encoded string. We have some survey question.txt. There are objects being created. There's decoding some feedback. We have another function. We have W script, which is going on, which we saw that attackers like to use, native living off the land techniques. There's still some more. Looks like the survey is going out to this detail account, and then we see here that they're trying to run PowerShell. There's commands here. Just more as you look at it, it just looks more and more malicious as it goes on. Some more functions, which is RS binary to string. And let's just see, that would be the end of the script. If we just keep going down, we can see other things. So this is the actual survey. So it looks like these are the questions that they're coming up with. They want to look for feedback to help improve employee relations and invest in the future of their employees. So it says it's an anonymous survey, which gives us the opportunity to express what you think about the company's commitment to its employees. So there's a couple of questions here, some random little bit of source data here, looks like from an image. And then thank you for your feedback. All participants will be entered for a draw for a chance to win a trip to the South Pole. So that is just an overview of it. So if we're looking, it's saying that there are 5 functions. Window on load, so automatically executes when the HTA loads and executes the get questions functions, what we saw. So it tries to make some external requests and ultimately runs the base64 encoded and the provide feedback function. And the provide feedback function gathers some data about the computer, makes some external requests, and ultimately executes something we need to analyze. The base64 decode will take the string and convert it to binary. And then the RS binary to string takes that binary and converts it back to string. So it says we want to understand any real actions that's being performed. These are usually denoted by the create object, which is what we saw, which was those Internet Explorer applications, the W script.network, and the W script shell. So W script.network connects to the computer's W script networking elements to uncover information, and the W script shell is to execute commands on the computer. So we can go down here and we can start looking at the actual application, the questions. So the first one's what is the title of the application? So we went all the way back up here. We can see, we remember it was the Best Festival Company Developer Survey. So this should be good. So which VB script was the function acting as if it was downloading survey questions? So that was one of the first functions. So it should be get questions. This one. And it says, what URL domain, including subdomain, is the questions being downloaded? So we see here that it called Internet Explorer, and it's navigating to this survey.bestfestivalcompany.com /survey_question. So it should be this one, because there's no file that's it's looking for. This won't go all the way to the end. All right. Let's see. So it says Malware seems to be using typo squatting where domains look the same as the real one. An attempt to hide the fact that the domain is not intended. What character in the domain gives it away? So we see survey.bestfestival. Oh, here we go. Right here. These 2 I's, instead of just festival, they misspelled it by adding another I. So we can quickly look at it. You would think that you're on the right domain. So it should be I. It says malicious HTAs often include real looking data like survey questions to make the file seem authentic. How many questions does a survey have? So remember that was near the bottom of this after we got past the script. So it's like we're here. Here we go. So we had 1, 2, 3, 4. What's our fifth one? We have 4 questions. There we go. It says, notice how even the code social engineering persists. Fake incentives like contests or trips hide in plain sight, building trust. The survey entices participation by promising a trip to where? If you remember, that was the South Pole. So they thought they had a whole expense paid trip, so they were weekly mission. Oh, get 50% XP. So the HCA is enumerate information from a local host by executing the application. What 2 pieces of information of the computer is running this being on exfiltrated? We should provide 2 object names separated by commas. So if we look back up here, I think there's a hint that it was the wscript.network is what we need to look for, or the wscript shell to execute. So go back up here and we look for wscript. Oh, here we go. So in this wscript network, they're looking for the computer name and the username. So username. It says what endpoint is the data being exfiltrated to. So right under here is going to this bestfestival.com, but there is a details. So it should be details. So it says what HTTP method is being used to exfiltrate data. So since it is using, there's no post command. So if there's not a post command, remember HTTP uses GET and post request. So it should be a GET request. All right. And it says after reviewing the function intended to get the survey questions, it seems the data from the download of the questions is exactly being executed. What is the line of code that executes the contents? So, questions been executed, provide feedback. And this is actually is this the execution of code? Right here. I wonder if it takes this into account. Okay. This one. No, it's not that one. What line of code executes the contents? Oh, sorry, maybe the whole thing. Actually. There we go. Should be that. Yeah, there we go. And it seems as if the malware site has been taken down, so we cannot download the contents of what is executed. Fortunately, one of the L's created a copy when the site was active, so we get to download the contents here. But I don't want to do it on my regular box, so I am just going to copy this link. I'm just going to copy this link. Then we're going to go here and take a look at it. Now if we go here. All right, so here is the actual string. So now we want to actually decode it. So we can use CyberChef, which is a tool that we have been using several times this Advent of Cyber. So getting really familiar with it. Go to CyberChef. Let's just take this code and let's decode it. So we put it here. If we don't know what it is, remember we can always use this one called Magic. Where were you? It looks like base 64 to me, but if you take a look at it and you do Magic, Magic will try its best to figure out the code. So it thinks it is base 64. So if we go ahead and we do from base 64, so we can decode it. This is the actual function right here. Function, binary. And we have all this right here. So it says, what was the popular encoding, which we know it was base 64. And then our next one is decode the payload. It seems as if the additional steps were taken to hide the malware. What common scheme can be used in the script? So script still is, scroll down, we can see everything's kind of just thrown off right here. But if we look, looks like they are, let's take a look at this whole thing. So this is the function, getting an object, and they're getting a character. So it's a character to array, it's a 2-character array. And in this, they are going, and they say that they are C minus GE 65. This if statement has to be true. And if it's true, it's taking this letter, minus it, the value by 65, and adding 13. So it looks like it is rotating characters, which would be a rotation 13, which would be rot 13. And if we check on this, give us, yep, we got that one. So it says either run the script or decrypt the flag value using tools such as CyberChef. So all we can do, because this looks like it's the flag, so we search rot 13. We can put this here, and then now we have our flag. We can paste this. And we should be done with this one. We can go ahead, if we wanted to, was check the key for side quest number 4, which is another HTA file. But the side quest hub is a little bit more challenging, so it'll take a while. And actually, once the side quest room is unlocked, we can't actually show any workarounds or any streams of that until it is done. So we'll just go ahead and check off these two, just for sake of time. And now that this is done, we're done with this day. We have one more day and we'll be all caught up. So we go back to Wareville. We have today's room, which is C2 detection. So go ahead and click on this. And we scroll down. Okay. Let's just clear this out. And we're on the last story. So if you are tuning in, we did finish days 19 through 21. So we're wrapping up with today's room. So in this story, we are that the TBFC has been very wary since the last series of attacks by the underlings of King Malware. They're on full alert for anything happen, but they are getting restless. It's too quiet. So Sir Elfo of the TBFC takes initiative and proposes to hunt for command and control traffic using a meticulous collected network traffic. C2, our command and control environments, are popular with all hackers. Every nation state, they do want to try and get in a box, have a way that they can exfil and extract data or download their scripts, which you saw in the last room when we broke down exactly what it was, what that HTA file was doing. So majority of the TBFCLs object. They don't have enough time to go through the network traffic. So they have Sir Elfo says that he has a powerful tool. So they'll present with us Rita, which is the real intelligent threat analytics. So we'll just need to convert our PCAP files to what's called Zeek logs. And then from there, Rita will do the rest. So I'll go ahead and close without saving this. Let me clear this just in case. So we will convert a PCAP to Zeek logs. We'll use Rita to analyze them, and then we will analyze the output of Rita. So we will not actually be needing our attack VM. Looks like something else will be provided. So I'll go ahead and shut this down. And I will start our target machine. While that is going, I'll just say check. And we'll learn about the overview of detecting C2 traffic with Rita. So Rita is the real intelligent threat analytics. It's an open source framework created by Active Countermeasures. They are very good. They do have a lot of trainings in Active Countermeasures, especially for blue team work. So if you are interested in this type of things, detections, logs, all that, Active Countermeasures I think they have like a free class like every week or every month. So often they have a Discord, which is active. So it's a great place to learn. So at its core, its functionality is to detect command and control communication by analyzing network traffic. Its primary features are C2 beacon detection, DNS tunneling detection. It detects long connections, data exfiltration. It checks for threats, intel feeds, scores the connections by severity. It shows the number of hosts connecting, and it shows a date timeline in which it was first discovered. So it's all about analytics. So it correlates several captured fields, including IP addresses, ports, timestamps, connections, durations, among others. So this is all the things that it will collect information on. So especially if a C2 is just doing a bunch of DNS queries, it will try and it will take a look at that, any type of random subdomains, and just the value of data over time that's going across non-standard ports over HTTPS or DNS. So Rita only accepts network traffic from Zeek. Zeek is an open source network security monitoring tool. It's not any type of firewall, IPS, or IDS. It does not signature or make specific or use specific rules to take action. It just observes what is going on. So Zeek will analyze and converts its input into a structured, enriched output. This output can then be used in incident detection and response, as well as threat hunting. So out the box, it covers the 4 types of NSM data, which is transaction data, summarizing records of applications, and extracted content data, files, artifact, or executables. So we'll start by actually converting to Zeek logs. Let's get this running. And if we just ls, we can see that we have this PCAPs folder. And if we actually ls into the PCAPs folder, there are Rita challenges, there's a sync wrap, PCAP, PCAbox. So what they want us to do, they say Zeek logs directory contains the Zeek logs, and these were created by parsing a PCAP file. So we will parse one ourselves. We'll take a look at the output. So if we do Zeek, we say read PCAP. We'll use PCAP's folder, and we're going to use that async.wrap. We're going to put it in Zeek logs, a sync wrap. Okay. So they're now said they're going to save it to the Zeek logs folder. And then after this, they want us to actually take a look at that folder. So we'll cd into our folder. And we will then list this in there. So we can see these are all the files, all the logs that it created. And for using the reader, we don't really need to know what's in these logs, but we can always cat them to find their context. So now we will analyze it with reader. And we will do that by using reader's import function. We'll go into this folder, and we're going to create an actual database, which is called async. Let's just make sure everything gets spelled correctly. And we will let this run. So this is actually creating the reader, the database. So now that reader has parsed and analyzed our data, we can view it by using the command reader view and then the actual data name, which is reader will view and then the async wrap. Now that should run, and let's just full screen this. So this is what reader's going to look like. So this is the terminal command. Am I missing something? I feel like I'm missing this whole side right here. Pretty weird. Okay, so it shows 3 elements, which would be the search bar, the results pane, and then the details pane. Actually, let's just full screen this and go to another one because it may just be getting cut off. Let's see. Yeah, there it is. So this is the detail pane right here. Let's just get out of split view. So it says in the search bar, if we ever wanted to search, we just need to hit the slash and we can search for different fields. And then while we enter the question mark, we can see all of the different search fields. Let's give that a try. So if we let's put the question mark now. And then these are all the search fields that we can use. Severity, the source, the destination. We hit escape, we will be done with that. And then let's just check right here. Now, if we go down here, this is all of the search that we saw, the severity. Well, this was the results pane. So we saw severity, the source, the beaconhood, the likely. So if we check right here, oh no, this is this is all the results pane, everything here. And then we need to, so here we can see that we had a interesting fully qualified domain, which was this sunshine.bizrate.cloudflare, and this was the IP address that was being used. Then we have the detail pane, which will give us our threat modifiers that we see here. It will give us the rare signature, which usually points to unusual patterns that attackers might overlook. The prevalence, which analyzes the number of internal hosts communicating with the specific external host, the first scene, and the missing HTTP header. So here's where we find out the metadata, the connection count, the bytes being sent. And now that we covered it, it says let's focus on the reader. So, for example, the first string threat modifier is relatively low due to the small time frame of the packets being captured. This can affect the severity score. And it says if we were to look at this fully qualified domain and we did a quick search of it, it will say that it's flagged as malicious. So go ahead and check the destination IP as a second entry as well. We're lucky to have found the indicator of compromise immediately. So that's just using the sample file that's right here. So read include a rare signature threat modifier. This inclusion indicates that the combination of certain parameters, for example, SSL certificate details related to this connection, is uncommon compared to the rest of the analyzed traffic. Malware C2 connections often create unique TLS pattern handshakes that differ from those of browsers and legitimate clients. So if we go down, we're actually going to we're going to be analyzing another file, which is the reader challenge PCAP, and it will let us answer the following questions. So if we go back through here, and can we actually exit out of here? I wonder if Control C works. Okay, so we're going to do the same exact thing that we just did. So this time, everything will be in the PCAP's reader challenge PCAP. So if we use Zeek to read, actually, before we do this, let's make a new directory, and we will actually let's go back one. Directory, and let's call it reader challenge. Then let's use Zeek. I think this was what's this called again? Oh. We will do this in the Zeek logs reader challenge folder. So we'll let it build that out. And remember, we CD'd here into logs. We LS that. You can see all these logs here. Now, if we go back up and import these logs, we'll just name this reader underscore challenge. We'll let that run so it builds out the database. And once we're done, we will just view it. So we scroll back up and we say reader view. We'll say reader underscore challenge. And we will let this now run. Now, here we go. Go back here. How many hosts were communicating with malware.net? So if we go here, we have malware.net showing 1, 2, 3, 4, 5, 6 times. So this should be a 6. It says which threat modifier tells us the number of hosts communicating with a certain destination. So under threat modifier, we have prevalence. So it looks like that should be the one. Should I spell it correctly? So it says, what is the highest number of connections to the rabbithole.malware.net? So if we use these, we could just use our arrows. We have 31 connections here, 40 here, 38, 29, 21. It's like 40 is going to be the largest one we have. So now it's asking us, which search filter will we use to search for all entries that communicate to rabbithole.malware.net with a beacon score that is greater than 70 and sorted by connection duration descending. So to do that, we actually need to, remember, we need to search for this. Let me just copy this just in case. So to search, we first need to hit that. But if we want to know our search terms, what can we hit that? And now, we can see here, this is actually giving us a nice example. So if we take this destination, private malware, and we put beacon. Remember, it was greater than or equal to, and it should be 70. And then if we do this sort, and we say the duration dot work. Just copy this just in case. Okay. Okay, maybe something is wrong. Oh, here we go. We're out there. So there we go. So that actually looked, that gave us 3. So if we go back here, copy this. This should be the filter. That works. So it says, which port did the host 10.0.0.13 use to connect to rabbithole.malware.net? So now, if we go in here, we look down at this .13 address. Oh, let me get out of the search restriction. And there we go. We see use port 80 over here to connect. So if we run this back over here and we type in 80, we should now be finished with this room here. And we are all done and we are all caught up. So we are on day 22 out of 24. If you did enjoy the video, please do us a favor, like, subscribe, and hit that notification bell so you can stay up to date as we go through the rest of these TryHackMe Advent of Cyber campaigns. The next video should be, Livestream should be either Sunday or Monday, just because I'll be traveling for the next 2 days, so I won't actually be able to complete it during the time frame, but we'll have fun. We'll get caught up. So if you thought of any videos you may want me to do, any topics on cyber you would like to cover, please do us a favor and drop a comment down below, and we'll be more than happy to create one for you. Hope you have a great day and happy holidays.